Welcome to the DIY Honda Garage channel. DTC P0616 refers to a malfunction in the starter cut relay diagnosis circuit, which affects the Honda Accord models from 2012 to 2017. The starter control system plays a crucial role in preventing the starter from accidentally engaging when the vehicle is not in proper conditions, such as when the shift lever is not in the park or neutral end positions for continuously variable transmission (CVT) models, or when the clutch pedal is not depressed in manual transmission (MT) models. When conditions are not right, such as the accidental pressing of the engine's start-stop button, the powertrain control module (PCM) intervenes to stop power to the starter cut relays. Notably, the circuit comprises two starter cut relays connected in series, including a diagnosis line that monitors voltage between these relays. If there's an issue detected, such as an open malfunction or a low voltage signal for specified durations, the PCM will store this DTC. Understanding the various functionalities and configurations of the starter control system is essential for accurate diagnosis and repairs. In conclusion, resolving DTC P0616 involves understanding the starter control system's intricate workings and effectively identifying any faults within its components. Each step, from inspecting starter cut relays to verifying the PCM's function, plays a crucial role in diagnosing the problem accurately. The systematic approach outlined allows technicians to analyze symptoms and troubleshoot effectively, ultimately ensuring the vehicle's reliability when starting. Regular preventive maintenance can also significantly lessen the chances of encountering this DTC in the future. By adhering to these guidelines and following logical troubleshooting processes, technicians will achieve successful repairs and maintain the integrity of the starter control system in Honda Accords from 2012 to 2017. The error described by DTC P0616 pertains to a malfunction in the starter control system, designed to prevent unintended starter activation. At the heart of this system are two components: Starter Cut Relay 1 and Starter Cut Relay 2, which are connected in series. This arrangement serves as a safeguard, ensuring that the starter does not engage when inappropriate conditions exist. For instance, if the vehicle is not in the right gear position, or if the engine is already running, the PCM will disable the starter operation. Additionally, the PCM monitors voltage levels between these relays through a dedicated diagnosis line. When this diagnosis line reports voltages at or below 1.29 volts for a specified duration, the PCM recognizes a potential failure and registers the DTC according to its internal logic. There are several possible causes for the DTC P0616, each of which could lead to the malfunction in the starter cut relay diagnosis circuit. One common issue may arise from the starter cut relay 2 circuit failing to activate properly. This malfunction prevents the PCM from receiving the correct signals needed to manage the starter operation. Another potential cause may be a short circuit to ground within the starter cut relay 2 circuit, which can lead to low voltage levels being sent back to the PCM. Lastly, there could be an internal failure within the PCM itself, causing it to incorrectly register the status of the cut relay circuits. Each of these causes must be investigated during the troubleshooting process to ascertain the true source of the problem. When dealing with DTC P0616, drivers may experience several symptoms indicating a problem in the starter control system. A primary symptom is the engine failing to start, as the starter may not receive the necessary electrical signals to engage. Additionally, the starter may remain completely inactive, even when the start-stop button is pressed. suggesting that the system is purposely preventing operation. Alongside these mechanical issues, there may be indications of dashboard warning lights activating. While the malfunction indicator lamp, MIL, may not illuminate immediately depending on conditions, the presence of this DTC alone hints that a system check is necessary. Observing these symptoms can guide technicians in diagnosing the exact issue related to the starter function. The first troubleshooting step for addressing DTC P0616 involves checking the operation of starter cut relay 1. This requires inspecting both the relay itself and the associated wiring to ensure that it operates as expected. Technicians should confirm that the relay engages properly when required and that there are no open circuits interrupting its functionality. This can be accomplished by using a multimeter to measure resistance and continuity across the relay's terminals, verifying that electrical connections are intact. If relay 1 is found to be malfunctioning, it will need repairing or replacing to restore normal operation. Establishing that this initial relay is functional is vital before moving on to investigate subsequent components in the starter control system. Following the assessment of starter cut relay 1, the next step is to inspect starter cut relay 2. Similar to the previous step, technicians should test the relay by examining its voltage levels when engaged. If relay 2 does not receive adequate voltage or fails to engage when it should, it could indicate an internal failure or a wiring issue within the connected circuits. Additionally, checking the integrity and condition of the wiring leading to and from this relay is essential. Any signs of wear, damage, or shorts should be noted and rectified. If this relay is deemed faulty, it should be replaced to allow for proper system functionality, which is crucial in diagnosing the broader starter control issue related to DTC P0616. After ensuring that both starter cut relays are functional, it is now imperative to assess the powertrain control module, TCM, for any faults. This step involves testing the various input circuit signals that the PCM receives from the starter relay circuitry. Special attention should be given to the voltage readings on the diagnosis line to determine if they fall within the expected ranges. If the signals are abnormal, or if the PCM fails to respond correctly, this might indicate an internal fault within the PCM itself. Depending on the test outcomes, reprogramming, recalibration, or replacement of the PCM may be required to rectify the DTC P0616 issue effectively. Confirming that the PCM operates as intended is critical for resolving the starter control system problems. Upon completing repairs associated with DTC P0616, the final repair verification step is crucial for ensuring that the issue has been resolved. Start by clearing the stored diagnostic trouble codes, DTCs, from the PCM to reset the system. Once cleared, test the vehicle's starting functionality to confirm that the engine starts smoothly without any hindrance. Additionally, it's essential to monitor the vehicle for any potential reoccurrences of the error code. If DTC P0616 does not reappear during subsequent drives, it is a strong indication that the identified issues were successfully addressed. Conducting this final verification step allows for assurance that the corrective measures taken were indeed effective and that the starter control system is operating properly. To prevent issues related to DTC P0616 in the future, implementing a robust preventive maintenance routine is advisable. Regular visual inspections of the starter cut relays and associated wiring can help identify potential issues before they escalate. Technicians should particularly focus on checking all electrical connections for signs of wear or corrosion, as these can significantly impact the functionality of the starter system. Additionally, ensuring that the vehicle's ground connections are clean and secure is vital. Poor grounding often leads to erratic electrical behavior, routine maintenance helps keep the starter control system in optimal condition, thereby reducing the likelihood of DTC P0616 arising down the line. Please like and subscribe to the channel. See you next time.